In problem number 23, we are looking for a job here. So recent research indicates that 76% of college graduates had a job within 6 months of graduation. We are going to look at a sample of 75 college graduates. We're going to find the indicated probability rounding to 4 decimal places. So what's the probability that exactly 50 have a job, more than 45 have a job, fewer than 30, and would it be unusual if more than 65 have a job? Well, this is binomial because they either have a job or they don't. Okay, they either have or don't have a job. So that means we can use binomial PDF and binomial CDF to find these probabilities. So first of all, probability exactly 50, that's P of 50. So that's going to be binom PDF. And our total is 75. Our probability that any one, so n is equal 75. And then our probability that any randomly selected has a job, that's our P, probability of success, 0.76. So 0.76, and then our x that we're looking at is 50. So going to the calculator, second variables, we want to go down to binom PDF, trial 75, P is 0.76, and x was 50. 0.0185. So 1.85% chance that exactly 50 out of 75 would have a job. What's the probability that more than 45 would have a job? So that's x greater than 45. Remember that binom CDF gives less than equal probability, so we have to look at the complement event here. 1 minus the probability of the opposite. So if you're not greater than 45, you're less than equal 45. So this is going to be 1 minus binom CDF. (75) is our n, P is 0.76, and x is 45. Let's go ahead and key that in. So 1 minus, second variables, scroll down to CDF, trial 75, P 0.76, and our x 45. 0.9985. And then probability that fewer than 30 would have a job, so that's x less than 30. So less than 30, we have to use a less than equal. If you're strictly less than 30, that means less than equal 29. So then we can use our binom CDF with n is 75, P is 0.76, and then our x is 29. Let's key that in. So 75 and 0.76 are already in there. We just have to change the 45 to 29. So this is really small, 6.817 times 10 to the negative 12. So that means move the decimal 12 spaces to the left. So it's 0.000000000000, 11 zeros and then a 6. So we're rounding to 4 decimal places, and this would be 0.0000. So it's 0 to 4 decimal places. And that happens sometimes. If you have a probability that's extremely small, sometimes you get this answer in scientific notation. That's what the E means. And then last, we want to know probability greater than 65, and is it unusual? So again, we have to look at complements because we have to write it in terms of less than equal. So the opposite of greater than 65 is less than equal 65. So 1 minus probability x is less than equal 65. So that's going to be 1 minus binom CDF. N is 75. P is 0.76. And then X is 65. So 1 minus second variables. So binom CDF. We just have to change that 29 to a 65. There it is, 1 minus binom CDF, 0.0075. And what's important about that is it's greater than 0.05. Oh, no, I'm sorry, 0.075 would be greater than. This is actually less than 0.05. So yes, that is indeed unusual.